Hello viewers, welcome once again to Jukes Online Maths class. If you can recall, in my previous video I premiered the concept of indices as well as the basic laws regarding indices. So today we'll be looking at another phase of indices, which is indicial equation. But before that, don't forget to subscribe to my YouTube channel at Jukes Online Maths class so as to get notified whenever I drop a new video. And as well, you can follow me on Facebook also at Jukes Online Maths class so you can enjoy more of interesting topics in mathematics. Okay, let's enjoy the topic. When we talk of indicial equation, automatically we are making reference to what? Equations involving indices, as we have one on the board. So how do you go about solving questions as regards to indices? Okay, let's see the solution of this question on the board. We have two equations in this case involving indices. Then how do you go about finding the value of x and y in these equations respectively? Now, for me to solve this equation, since I'm having two equations, let me bring out the equation. We have 3 raised to the power x plus y equals 9 raised to the power y plus 3. And as well, we have 2 raised to the power x minus y equals 8 raised to the power x minus 3. Now, I'm asked to find the value of x and y. And the x and y here in question are the powers of these bases. How do I go about solving this? It's very simple for applying what? Indices. How do you go about solving this? Now look at this. For the first equation, I have this as my equation 1. I have this as my equation 2 because I'm having two equations here involving indices. The first thing I have to do is what? For the first equation, I will try to make the both sides of the equation to have the same base. And as well, the same thing is also applicable when it comes to equation 2. How do I make the first equation to have the same base? Already the 3 here is the least base in this equation 1. So I will try and make 9 to be in the base of 3. Automatically, I can do that because 9 is a multiple of what? Of 3. When I do that, I will have for the equation 1, 3 raised to the power x plus y equals to, since 9 is a multiple of what? Of 3. I can express 9 in index form as 3 raised to the power 2. 3 raised to the power 2 is automatically equals to what? 9. Then in bracket the existing power, which is y plus 3. This is still my equation 1, as you can see. Then, applying the same concept when it comes to equation 2, I have as well 2 raised to the power x minus y equals 8. Be a multiple of 2, which means I can also express 8 in index form as 2 raised to the power 3. Then, in bracket, the already existing power, which is x minus 3. This is my equation what? Equation 2. Okay, let's keep solving. If you consider this equation 1, you can see that the base in the left hand side of the equation is automatically equals to what? The base in the right hand side of the equation. I'm having their respective bases as what? As 3. If that is the point, I can simply cancel them out. Then the same thing is also applicable when it comes to equation 2. They are having what? The same base. When you compare the both sides of the equation, I will do likewise, cancel out the whole basis. So now you can see that I'm now left with their respective powers. And the powers in question there are where I have the variables x and y, which I'm asked to find. Okay, for the equation 1, I'm having the powers as x plus y equals 2 in bracket y plus 3. This is still my equation 1. That's for the equation 1. Then for the equation 2, I have x minus y equals 3 in bracket x minus 3. This is my equation 2. Now, I have these two equations. Automatically, they are trying to form a linear equation. Let's keep going. I can expand this, and as well, I can also expand this. When I do their respective expansions, I'll have the equations to be in this form. I'll have the first equation as x plus y equals 2 times y, I'm having 2y. Then 2 times plus 3, I'm having plus 6. My equation 1 still. Then for equation 2, I have x minus y equals, I will expand the bracket simply. 3 times x, I'm having 3x. Then 3 times minus 3, I'm having minus 9. This is still my equation 2. Now if you look at this, the variable there are kind of scattered. I have to do what? Collect like terms. How do I go about collecting like terms? Once you are collecting like terms in mathematics, you have to be very mindful of the signs. Automatically, when plus sign crosses the equality sign, we'll have minus sign. And also when minus sign crosses the equality sign, we automatically have what? Plus sign. So when we are collecting our like terms here, we should be mindful of their signs. Now for equation 1, I want to collect like terms. How do I collect like terms when it comes to equation 1? First of all, I have x plus y. I want this 2y to cross this equality sign to come over to this side of the equation. When I do that, it is having a positive sign here. When it crosses, I'm having minus 2y equals what? 6. Still my equation 1. The same thing applicable when it comes to equation 2. I have x minus y, then plus 3x, crossing the equality sign, I will have minus 3x equals what? Minus 9, equation 2. When I go further to collect their like terms, I'll have this x, y minus 2y will automatically give me minus y, as you can see. Then equals to 6, my equation 1. And as well, x for equation 2, minus y minus 3x, minus y, okay, x minus 3x, sorry. I have here x minus 3x will automatically give me minus 2x, then minus y equals minus 9, equation 2. Wow! If you look at this, you observe that we have formed them two linear equations. And to solve these two linear equations, I have to use what? Simultaneous equation. So how do I resolve this? How do I solve for the value of x and also the value of what? Of y. Now when you are solving two linear equations, the same time, automatically we have to make use of simultaneous linear equation. We have the first method used in solving simultaneous linear equation. We have the elimination method, we have substitution method, even we have Cramer's rule when it comes to matrices, and lots of them, even graphical method. So let's use the elimination methods to solve this, so it will be very easy and simple. Now, if I want to use the elimination method to solve this simultaneous equation, that is for the value of x and y respectively, okay, I will check for a sign that when I attach it here, I want to eliminate y in question. So what sign am I going to attach here so that this man and y will be eliminated from this equation? You see, if I attach plus here, minus y plus minus y will automatically give me what? Minus 2y. So it has not been eliminated. So you can see that the best sign to attach here should be minus sign. When we do that, okay, x minus minus 2x will automatically give me what? 3x. Exactly. Then minus y minus minus y. Minus minus will automatically give me plus. Then minus y plus y will automatically give me 0. So y has been eliminated in this case, which is equals to 6 minus minus 9 will automatically give me 15. I'm having this. So how do I get the final value of x? You see, for me to get the value of x, I have to divide both sides by the coefficient of x. And the coefficient of x here in question is 3. So divide here by 3, divide here by 3, such that I will have x equals 15 divided by 3 will automatically give me 5. You see, I've gotten one of the variable, which is 5. Then I'm left with solving for the value of y. And to get that, it is now very easy. Since I have gotten the first variable that I'm asked to solve for, then solving for the other variable will be what? Very easy. Now, how do I solve for the other variable? Once I substitute the value of x as 5 in any of this equation, be it equation 1 or equation 2, automatically I will get my what? The corresponding value of y. Okay, let me use the equation 1 and solve. Substitute x equals 5 in equation 1. And what is my equation 1? I'm having my equation 1 as x minus y equals to 6. Equation 1. Whenever I see x in equation 1, I will remove it since I've already gotten the value of what? Of x. When I do that, I will have that. I've seen x, as you can see here. Remove x and attach what? 5. I have 5 minus y equals to 6. Make y the subject of formula. When I do that, I'll have that minus y equals 6. 5 will cross over to the other side of the equation, as you can see. When we cross 5 over to the other side of the equation, I'm having minus 5. So I have minus y equals to 6 minus 5 will automatically give me what? 1. Then divide both sides by the coefficient of y, and the coefficient of y here is negative 1. So I have to divide by negative 1 by negative 1, such that I will have the value of y as minus 1. So we have it that in this equation that x that I'm asked to find is equals to 5, and as well y is automatically equals to minus 1. So these are the values of x and y that will automatically satisfy this equation, as you can see it on the board. So using indicial equation to solve what? This kind of equation is very simple. As you can see, this indicial equation led us to simultaneous equation. So whichever one it leads us to solve the questions will be very simple, provided we are conversant with our laws of indices. Okay, thank you for watching today. Remember to subscribe to my YouTube channel at Ojik's Online Math Class so as to get notified once I drop a new video. And as well, you can follow me on Facebook so you can be enjoying more of these interesting topics in mathematics. Have a nice day, everyone. Thank you.